In 1991, Guido created Python programming language, and from that point till 2018, he served as a benevolent dictator for life, which means he had a final authority in any major decision-making process related to this awesome programming language. In July 2018, he stepped down, and in December same year, a Python steering council was formed. The council consists of 5 members, and we are having a conversation with one of the members of Python council, Pablo Galindo. To go over some of Pablo's contributions so far, if you have used positional only arguments in Python 3.8, then that is something that was authored by Pablo along with few other people. He has been a core Python dev since 2018, and in 2019 and 2020, he was the second most active contributor on Python GitHub repository. He also maintains and improves the Python speed server, which is speed.python.org. Pablo works as a software engineer in Python infrastructure team in Bloomberg. So without further ado, let's get started with the conversation. Pablo, first of all, thank you very much for spending time, especially on the weekend, for this conversation.
A pleasure, always a pleasure to be here with you.
All right, so Pablo and me, we both work for Bloomberg, which is a major leader in financial data and analytics. Let's discuss what does steering council do actually? What is their role in the development of Python programming language?
Right. So mainly the main idea is that so Python is quite a big language. It's one of the most popular language in the world. And there's a huge amount of users of the language. And these different users have normally ideas for improving the language, things like adding new syntax or adding new functions in the standard library or things like that, right? Not only users, also the core developers of the language, the people that are actually developing Python also have these ideas. So the first thing the steering council does is that it basically acts as a filter of these things. It decides like what should be added to the language, both in terms of new features, but also in terms of like the grammar of the language, the how you write the language itself. So it acts as a first filter. Another thing it does is that it stays in close contact with the PSF. The PSF is the Python Software Foundation, which is the non-profit organization that manages the Python brand. And we stay in contact to basically try to see how can we use the PSF resources to speed up Python development. Usually this is using available funds to make sure that, for instance, if we need to do something else that requires money to be realized or some workload, so we can spend some of those resources on that. We also have a vision for the Python language. So this is like on the long term, what things should we work on? And this is obviously, we don't decide what people should work on or should not, because it's open source. Everybody works on whatever they want, but we kind of set the idea, right? We say, as a steering council, we think we should go this way, and we can try to, find resources from the PSF, but also try to argue with the core team on going that way. And lastly, we have the power to organize a bit the core development team. This is things like when there is code of conduct violations or things like that, we have, obviously as a last resort, but we have the power to eject people from the core development team if that is necessary. So we have some administrational powers there. And also if there is a dispute between core developers because two people want to add the two different things, or because someone doesn't agree with something that someone is doing, we have the last word on saying, okay, so this is how we're going to do it, let's do it this way, right? So that kind of things.
Awesome. Wow. So Python is the most powerful language, and you are one of those 5 people who has kind of the final say on important matters. So do you feel kind of pressure sometimes, because it's a huge responsibility, right?
Right. I mean, it's indeed a lot of pressure. Not only because when you do these judgments, it's not about like only what you think or what you don't think. Like what you do have, you need to have a good opinion on the matter. So normally it involves reading a lot, and like reading emails from people that have different concerns, reading the design documents. Like normally we are talking about hundreds of emails or thousands of emails. For instance, we are now discussing one of the new controversial additions, which is pattern matching, and that has almost 1,000 emails that you need to read to understand what people are thinking about it, and you need to take it into account to have a fair decision. But also, obviously, there is people that like features and people that don't like features. So there is a lot of pressure in the sense that you cannot make everyone happy. So at least some group of people will be not super happy. And people tend to be very passionate about the language. So like they normally express their frustration or their non-willingness to go a certain way in a very expressive matter. Let's say that way. But yeah, I mean, it's not it's certainly a position of responsibility. So with great power, great responsibility, and all that. But also it's a position of like reading a lot. You need to be prepared to have a lot of patience.
You need to have a lot of like serious listening skills, I guess. And
Indeed, yeah.
yeah, you said it very right. The great power comes with great responsibilities. So let's talk about your open source journey, because like open source is kind of, you need to really have passion for it. You don't get paid, right? And
Right.
you have 9 to 6 job, and on top of that you are doing all this work. So what kind of keeps you motivated? And let's talk about your journey as an open source developer. When was your first open source contribution?
Right. I think, yeah. So at the time I was studying my PhD, I'm a physicist actually. I'm not a computer engineer, or at least my background. I mean, I work as a computer engineer, but my background is physics. My PhD was about rotating black holes. And one thing that you need to do during research is that you need to do these high performance computing simulations, things like, synthetic images of black holes and things like that. So I coded a lot back in the day, but I didn't use Python. I used C++ and Qt
Mhm.
and plain C. But I started to learn Python back in the day to kind of glue different systems together. It was a perfect language because it's very easy to, quickly evolve, but also because it's very easy to interface with C and C++ in a simplest way.
Mhm.
So my first pull request actually to open source was because I was using some socket stuff, something about the networking module, probably the socket module. And the example in the documentation actually was wrong. I tried to follow that. It failed miserably. It was a very stupid thing. Something like instead of importing this, you need to import that. Something super ridiculous in the sense that it was very easy. No, it was not worth it. But I opened a pull request to Python, changing that particular part in the documentation. And it took 1 week to merge, even if it was 2-line changes. That shows you how busy people normally in the Python project are. Now I'm one of the people that are busy on the other side, so sorry if we take a lot reviewing your things. But that was my first pull request, and it was quite a interesting conversation also on how to make sure that the documentation was right. And I started saying, okay, well, if I can fix this thing, maybe I can fix other things. So I started actually looking at code instead of only documentation. Although I have to say that the documentation is actually super important. So don't think about pull request to documentations are small. They are not. But I say, okay, let's see other things I can help. And I don't know, I kind of fell in love with the project. It was full of very challenging things. It was very different from the kind of code I was used to do. And also the people, like one of my best friends now in the Python world were met when I started contributing to open source. So I think there is this sentence in the Python world that says, I came from the language, I stay from the community. And
Mhm.
it kind of is repeated every year to ad nauseum. But it's true, right? I actually started going there because of the language, and one of the things that makes me stay open source is the people, certainly. Even if it's something like you are not paying normally, on the other hand, you learn a lot. Like, when do you have the possibility of working together with people that are extremely smart, or with the creator of the language itself, or
Mhm.
for instance, with Judy Sullivan, one of the best persons that was the best developers that I know, and this is because I started to contribute to open source. So I think what keeps me going and keeps me motivated probably is 90% the people. The people are super important, and remember that engineering is mainly a social thing. So it sounds like it's about code, but it's actually about people. So have that in mind.
So when did you meet Guido, the creator, ever, and when did the first interaction happen? What was the time?
Right. So I met him. So when I became a core developer, there is this yearly meeting that used to be in person. Now with the coronavirus, things has changed slightly, as you can imagine.
Mhm.
There is this thing called the core developer sprint, and this is like a week that happens every year where all the core developers of the language that are active. There is some core developers that don't contribute anymore, but this is like around 30 people in total. So all the core developers of the language meet in one place.
Mhm.
Every year is different. For instance, 2019 was in the Bloomberg offices in London, but before was in Microsoft, and before was in Google, and every time is different. So that first year when I became a core developer, I went to Seattle, the Microsoft offices in Seattle, and obviously among all the core developers there was Guido, and at the time he was adding with Emily Morehouse the Walrus operator, and we had a lot of chat about the parser and the grammar. Like I'm mainly working on the parser in Python. I mean, I work all over the place, but mainly on the parser and the compiler. And so I was quite interested on that area, and because they were adding a new feature, I was quite like into it. So that's when I first started to speak with him. After that, we have collaborated a lot. Like one of the biggest projects that we have made, we have worked together a year together with Lisandros Nicola for adding a new parser to C Python. This was added on Python 3.9, and it was basically a year of collaboration with them. Yeah.
I see. All right. So, do you have any interesting experience working with Guido that you want to share? Because this term, BDFL, the benevolent dictator for life, was actually coined after Guido. So, is there
Right.
like any dictatorship kind of personality in him, or like you want to?
No,
Yeah.
it's very easy to work with him, and I would say that, I mean, he has a strong opinions, but he's very reasonable all the time. Like, he may think, the way to do this thing is this way, but he always listens to what you say, and most importantly, he actually considers what you're saying, because one thing is
Yeah.
listening to your things and say, yeah, whatever. But no, he does. And but one of the best things that I have working with him, apart from, that is very easy, is that his design skills are fantastic. Like, the ability to think about a system and have a good and a strong way to structure the different pieces and select how to do certain things. That is
Mhm.
something that only comes with experience. It doesn't matter how many books I mean, books will help and videos will
Yeah.
help, but like, that's something that only experience can give you. And one of the best experiences that I have with him is learning that particular way of thinking, right? Like his experience with designing systems, I mean, specifically Python systems, and in this case specifically parsers.
Mhm.
But almost every time I work with him, that's the major thing. I mean, he also obviously a very good coder, but I think where he's excelling at is this kind of design skills that he had. Like, the language has evolved a lot, so although he knows a lot about Python, obviously, as any other person, he cannot have everything on his mind. So right now, kind of the best way he actually interacts with people is with this kind of vision and the science, and that is top notch. So I'm quite happy to work with him, and learn those skills. Yeah.
Got it. All right. I was just kidding when I said dictatorship because like sometimes people don't know the real meaning about the BDFL and they might think
Right,
okay it means something else.
right,
So
right.
as a council member, like how do you guys decide like when you have a conflict, right? Like because as I said, like Python is the most popular language as per Stack Overflow in year 2021, and so you guys have a huge responsibility. So how do you like when there is a conflict, like is there like any voting process or is it like five of you just go together in a meeting room with some brainstorming and you guys basically decide that okay this is what we should be doing?
Right. The way we work is that mainly we try to have the same, like we don't do voting and the majority decides whatever, right? We try to have a unanimous, I don't know if I
Okay.
pronounce that correctly, but a unanimous voting, a vision, right? So we try to be all agreeing. So normally there is we meet one day a week. We have a 1 hour and a half meeting, and then we talk about the problems. We talk about our vision, like what we think. Sometimes we are all agreeing on the same. We are all on the same page, so it's quite easy. Sometimes, for instance, the most controversial features, obviously, we are not on the same page. So we try to find like compromises and where we stand, and we try to see also how strong are the disagreements. It's not the same thing that I say, well, I don't like X, that I say, well, I absolutely hate X, or I don't want to live with X. Right? It's two different strongly ways to disagreement, right? So we try to find ways of, and at the end of the day, we may one important thing to understand is that we may have personal preference over things, but when you are in this kind of position, you have to think of the big picture. It's not about what you like, it's about like what is good for the language. And many times, for instance, I don't like things, but listening to my colleagues in the steering council, I can see why something is good in the kind of long term on the vision, or like why is better, even if I personally don't like it, or I won't use it, right? So there is a lot of these conversations trying to make sure. And what is good or not is certainly not an objective truth, but it's easier if you look at it this way instead of what you like and what you don't like. Because if five people go into the same room and we start discussing what we like, we won't accept almost anything because we have different preferences, right? But if five people with a high knowledge about designing languages go to the same room and we try to convince each other to, and especially read, right? Like, and make sure that we understand the problems and the design space. Normally, it ends in a easy way of deciding. Sometimes it's still complicated, but it's easier than certainly just saying, no, I think this or I think that, right?
All right. So let's discuss about your election as a council member. So how does that election process and the nomination process works?
Right. So you need to be nominated. You need to be a core developer of the Python programming language to be elected, or you need to be nominated by one. So technically, everyone can be proposed as a steering council as long as a core developer proposes them. So once you are nominated to be a steering council member, what happens is that you kind of do a pitch, like you say what you have worked on, whether there are other expertise. You need to say as well, like why you think you will be a good member of the council, and what you will do if you are elected, or not what you will do, because it's not like, oh, I will have like $1 million and I will spend on this and that. It's more about like what you would like to steer the steering council towards. And the reason is because you are one of five members, right? Like you need to work with people. You cannot just promise X and then if the other four don't like to do X. So you need to think about where you're going to try to steer the thing on, right? Like I'm going to try to do these things, right? So if people like those things, they will probably like what you're doing. So then when you basically do the speech and you speak about like your achievements and why you have like good design skills, then all the core developers vote, and they can vote for up to 5 members, I think, or maybe all that they want, but I don't know. They vote people, right? They can say, oh, I want this person and this person and this person, right? Without order. And then the topmost 5 people that get voted are elected, and they're elected for a year, and then there is a re-election. Normally they are re-elected, but there is always maybe 1 or 2 persons that are out, depending if they steer down, or if someone was more popular this year or whatever. It's quite the actual thing is about trust, because it's not about like, oh, I'm going to do X. I mean, we all almost are saying the same things, right? We are going to make Python faster. We are going to make Python better, blah, blah, blah. I mean, I'm not trying to trivialize what we say, because it's quite important, but like at the end of the day, it's very similar things that we said. The important part here is the trust of the core development team in you, right? So, the core development team are the people that work on Python on a daily basis, and they know Python more. And what matters is that the people that know Python more trust you to take the decisions over them, right? So it's a lot of trust. And if they think you will be a good a good entity when there is like conflicts and things like what it's not about like if you will decide whatever they like. It's about that if you will take the time to understand the two different positions, and if in the past you have shown that, right? That's one important thing. Like what have you done in the past when there is like a conflict, or what have you done in the past when it was a tough decision? Do you like, does this person know all the code base or only contributes to certain parts? I mean, that is obviously fine. There is no need to know all the code base, but it's obviously things that matter to people. So at the end of the day, it's a matter of trust. But that's how the system works. They basically vote, and the 5 most voters.
All right, so we'll include
position.
those pages which has your nomination link,
Right.
as well as the election results. So we'll include all of that in the video description below. And how many core developers are there right now?
So we distinguish between active and non-active. I think the total amount of core developers that could vote is 70. So that's the total number of core developers. Active, I think, is around 60, or well, active is actually lower. But at the end, when they need to vote, they become active just to vote. So I think they vote like 62 or 63. You can see probably a bit more, but yeah, around let's say around 70 people that can vote. Actually, on the day-to-day basis, working on code, I will say 20 or 25, even less depending on the season. But yeah, that's people that have the title around 70. People that work on a day-to-day basis on the code base around 30.
Is it like anyone can go and contribute to Python?
Everybody can contribute to Python for sure. I mean, we encourage you to do that. The core developers are the people that merge PRs and they review your code and they take some decisions, right? I mean, the steering council takes the big decisions, if you may, I mean, or decided what goes. Actually, okay, let me actually structure that a bit more. So the core developers are the one that review PRs from contributors. So if you're interested to go into Python, so you say, okay, I have these improvements, and then you propose that, and then the core developers are the one that go there and say, oh, actually this is a fantastic idea, or actually this is not a good idea, and then review your code and go with you and say, okay, let's change it, let's do this, blah blah, and then eventually merge or don't merge your PR. But the core developers are always, when there is a big change that will have a big impact, the core developers are normally the people who write these design documents called Python Enhancement Proposals, or PEPs. Although everybody can write them, it's just that the core developers tend to write more of those because they're more changing more things, right? And those big changes, these are things like grammar changes or big new features or things that are going to break people code. So those changes then are written down in this format, and is the steering council the one that decides if the changes go or doesn't go. But the core developers are the one actually normally writing them. Again, anyone can actually write those documents. But yeah, that's what a core developer is. It's more like, again, it's about trust, right? It's like a lower level of the steering council, but those are the ones that will decide more or less for the small things and bug fixes and little features and small improvements or medium improvements, if they go or not, and they will normally work with you. I mean, I'm also a core developer, so I don't know why I say they. We will work with you, like fixing your PRs and make sure that it goes. But anyone can contribute to Python. Like you can just go to the backtracker or to GitHub and say, I want to add this feature, or I want to fix this bug, or I want to improve this thing in the documentation. So you open a new issue, you describe what you want to do, make a PR, and some of us will appear there and say, hello, let's review this PR, and hopefully it
Got it. So if someone wants to contribute to Python, they just go to Python GitHub page, look at the number of issues or enhancement requests that are open, and pick it up and start working on them, correct?
Yeah, that's true. Also bear in mind that one thing that I also didn't mention before in the last question is that the way you become a core developer normally is that you start contributing a lot. And once you contribute a lot, one existing core developer normally realizes that and then starts mentoring you to be a core developer if you like. Again, it's not only about power, it's about responsibility. It's not about like a title, you are a core developer now, right? A lot of people see it that way. It's a status thing. It's actually about more responsibility, because if something breaks, people are going to look at you, right? And this is something that you're not paid to work on. So if something breaks, you need to fix it the same way you add it for free. So it's more responsibility, right? But yeah, that is the best way to continue to, yes, is to go to the Python backtracker. This is bugs.python.org, or to GitHub directly if you don't want to fix bugs. And yeah, open a new issue on the backtracker. If you want to fix something, maybe there's an existing one. If you want to add a new feature, open a new bug and say, I want to add this new feature to the language. There will be some discussion, and then you can make a pull request. Bear in mind also that Python is a very mature project. This means that contributing to Python is certainly possible, and there is a lot of people that do. Even people in the university, you don't need to be an expert to contribute to Python. Maybe so to some areas you need to be a bit of an expert, but to some other areas you can be, a first year graduate if you want. There is people in high school that contribute to Python.
Wow.
The important part to consider is that this is a very mature project. Therefore, there won't be easy issues. Like, you need to be very perseverant, and then you need to spend some time filtering things, because it's also very big. So people go into the backtracker and say, wow, I have absolutely no idea what to pick on, right? And unfortunately, there won't be someone to say, oh, there is these issues that maybe you will like. You need to find those. You need to find what you like, or you like to do. Maybe you only like Python, so you can contribute to the Python parts of the standard library. Maybe you like C, so you can contribute to the interpreter itself and the C parts of the standard library. Maybe you like documentation only, and then you want to improve the documentation. So you need to find what you like. And even if you find what you like, you also need to find the subset of the area where you're comfortable with. And unfortunately, not even if you have a mentor, they won't tell you, here's some issues for you, right? You need to find those. That's how it works. So being Python amateur projects that is more challenging, is not the easiest project to start contributing. So if you are starting in open source, I won't advise to start with Python. You can certainly do that. There is people that do. I did that. But it's not the easiest way. So if you are starting to contribute to Python and then you're becoming a bit frustrated because it's not a good experience, maybe consider also something else before saying open source sucks. Because Python is quite challenging it also takes a lot of time to review your code. It takes 1 year to see your code out and people using your code, which is something that a lot of people contributing says, oh, I made this change and I want people to start using it, right? So in Python you need to wait a year. It used to be that you need to wait 2 years, which is even more insane, right?
So every release in Python now is like yearly, right?
Every year there is a new release. Yeah.
So right now, which is the latest version of Python 3.9, right?
The latest released version is Python 3.9 that was released last year. Was released by Gukas Lange, and the next release of Python that is going to be, I think, around October. Although I'm the release manager, I don't know the dates, but there is in some document you can search for Python 3.10 release schedule. I wrote that, so I should know the dates.
Okay, so 3.10 is most likely coming around October 2021.
It's this year. Let's say 2021. Yeah, coming to 2021. Like films now. When you see films now, they don't say normally April. They say at some point in 2021. So yeah. Exactly. Let's say at some point in 2021.
And so the thing I think about is, like, with films, and even if you are working for some big corporate, when you're planning a release, you have resources, like you have money and everything. This becomes even more challenging with open source. It's like you're working with a bunch of volunteers, and money is probably a problem too. So how do you do like capacity management?
Well, that's why we have a release manager. It's a person who is independent. Like, I'm a release manager not because I'm a steering council member. It's just because I decide to hurt myself with more work for free. So the release manager is like more responsibility, if you mean, and they are in charge of figuring out how to, not only make the release happen, but also all the problems coming with the release, like itself, right? Like, oh, this feature is broken. We need to, like games, when you're going to release a new video game and there is bugs, someone needs to decide, okay, we cannot release it this day, we need to release it next month, or new release day. So here's more of the same. There is a lot of bugs, and we cannot release a version of Python that is broken, or maybe it's slower or whatever, right? So we need to make sure not only that we make a new release date or whatever, but also we need to make sure that the people who needs to fix those fix them, because in a video game, again, they are paid by the company to do that. So if there is bugs, you need to fix them because that's their work. But here people are volunteers, so there is a responsibility and all that. Like when you are a core developer especially, If you merge a pull request of a contributor, you become as a core developer responsible for that code, even if you don't write it. So that's why it's quite important to be a responsible person. But also it's volunteers. You can just go to their home and say, hey, what is the patch, like,
You can fire them from job. Yeah.
Right, but you need to, right? Like, you need to say, hey, man, no, or woman, right? No, not cool, not cool.
Yeah.
You need to fix this, right? And so that's what the release manager does. It sounds like super fancy, like release manager, but actually
Wow.
it's just more work. And then the release itself is quite a lengthy process. It takes like 5 hours to do a Python release. It's a lot of moving parts involved, different platforms. You need to do artifacts for Mac OS, Windows, Linux. You need to sign them, documentation. It's quite a complicated process, and it takes like 4 hours. And it's not only like the final release. You need to release the alphas, you need to release the betas, the release candidates, and the final release. And that's a lot of releases. Yeah.
Wow. So like looks like being a release manager now, you need to work with people in a way that you need to
Yeah.
put some pressure without getting their egos hurt, right?
Yeah, it's like being an unpaid manager, literally. Like
Unpaid manager, yeah.
it's an unpaid manager. Yeah. When you see, so everybody hates you, but you don't get the money at the end of the month. So that's what it is.
I see. And even like you have 96 job as well. So you have this job and then you have this huge responsibility of Python programming language. So I'm pretty sure your weekends must be super crazy and busy.
Well, in the weekends, I try to kind of disconnect as much as possible, which is not always true, in the sense that I always, like, say, oh, I want to fix this, or I'm going to add this new feature. But it's quite important, especially if you are very involved in open source and you have many position responsibility, to find spaces to disconnect. I mean, I don't know, I don't only do Python, obviously, although some people think about that. As you can see, I play the guitar, and I play video games as well. And I have other hobbies, right? So it's quite important to find these spaces to disconnect. And it's about, like, some people see all things I do and say, oh wow, like, but you must be working all day because it's impossible to do things. At the end of the day, it's about organization, right? Like, find and being efficient. Like, like, if you're going to do something, like, focus a lot on that something, and then try to find spots to fit the different things. And if you're exhausted, sometimes it's impossible to just work like a machine, obviously. So if you're exhausted, also try to make sure that you are able to find those moments when you're starting to be a bit, like, burn out about things. Like, maybe you're not enjoying fixing something in Python, so obviously don't force you to do that. Or maybe you're not enjoying learning the new whatever song on the guitar, so don't force you to do that, right? So it's about, like, understanding when it's not wise to continue doing what you're doing, and find those spaces for yourself. So watch a movie, or like do a walk, or travel when you can travel. Certainly not now. Don't travel.
No, no,
People,
yeah.
don't go there. But yeah, or start a tiny project, right? Like, sometimes I say, I don't want to do Python. Let me do Rust, right? So I started to code a lot in Rust from the last year. So I started doing small projects in Rust to learn the language and to have fun. So it's all about finding a good balance. So on weekends, I normally try to not do Python, although sometimes I fail.
Yeah.
That's the idea.
All right, cool. So before this conversation, I did a little survey on what are the topics that people want to discuss in this conversation. And some of my subscribers on YouTube channel asked those questions. So we'll just go over those questions. So the first question is, Python is amazing. People love it. People love the convenience. You get things done very fast. And there is a cool, like, ecosystem. But they say that JavaScript and Python both are interpreted languages, but JavaScript is so fast. Like, why Python is not fast, and what is being done to improve the speed? And since you're involved with the whole Python speed initiative as well, I would like to know your thoughts on this.
That's a very good question. So Python and JavaScript have both being interpreted languages. They have very different realms of application. JavaScript is mainly on the browser, and is mainly not the main way to do interactivity on the browser. All the main browser like Google Chrome, they invest a lot of money to make sure that JavaScript is as fast as possible on Google Chrome because they want people to use Google Chrome. So this is B8, I think, the JavaScript engine of Google. I always have the names going back and forth, but the main difference is that like JavaScript, also there is like the JavaScript, right? Like Python has also many different implementations. There is CPython, which is probably the one that you're using. That is the one that is everywhere, but there is others. There is PyPy, which is also much faster, and we can go into why, but also is less compatible. But that's the balance. Although it's becoming better and better with time. The amount of advanced technology that JavaScript has is ridiculous. Like it has JIT compilers, it has extremely efficient implementation of the VMs, etc. While Python, although it has some resources, is mainly still is a volunteer project. So the main implementation, at least, which is the one that is everywhere, and it's probably the one that you are complaining about being slow, is still people that, sure, I mean, we know our thing. We are not like random people, like without knowledge trying to make an interpreter. But certainly we don't work 8 hours a week or 9 hours a week for the full day. We're not paid to do this thing full time to entire corporations, and also we are not organized. Many times I work on things like I like, you work on things that you like, he works or she works on things that she likes, while in the company they say, okay, we are going to have 10 people working on speeding these things up, and the 10 people work on that, right? So it's quite, that is one reason. The other reason is that CPython and Python therefore has a huge amount of exposure on the C API. That's quite a technical detail. I will try to explain what it means. So you can have code written in different languages, especially normally compiled languages, things like C++, C, Rust, etc. And you can expose that code into Python. So for instance, if you use NumPy or if you like machine learning and you use TensorFlow and all those APIs, normally that code is not actually Python code. It's C++ code or C code or Rust sometimes. And Python offers a way to grab that existing code and kind of make a Python API. So when you call a function, you think you're calling a Python function, but it's an actual C function.
Yeah.
Right. That is one of the reasons Python is so popular, because there was a lot of existing libraries in C and C++ that you could actually now use in Python using these APIs. And that's actually the reason it's actually popular nowadays, because you will say, but if Python is so slow, why is using finance, or why is using for machine learning, which is like super heavy calculation? Well, the reason is because those calculations run in C and C++, and the actual way to structure your code and architect the higher levels, which is more difficult to do or more unmaintainable or more slow or whatever, you do it in Python, right? You pay some.
Just to summarize, you get Python convenience and C++ speed, actually.
Exactly, right. So it's not about like, I mean, it's slow if you want to do absolutely everything in Python. That's true. And the same way, by the way, JavaScript is also slow if you want to do everything in JavaScript. Like JavaScript itself is much faster than Python. But if you start like saying, okay, let's do a machine learning library in JavaScript, you're going to have to put compiled code into the mix. Like even an interpret language can go so far, even if you put all this money, right? So in particular, Python, this kind of bridge between Python and other languages is called the C API. It's good because it uses the C programming language, and the reason the C programming language works is because it has a universal stable API, which we can explain what it is, but so it has something magic, unicorns. It has something like that. So the idea is that the surface level, like the amount of functions that you can use to interact with Python, is super big, like thousands of functions, while JavaScript probably has hundreds. And the problem is that that flexibility comes with a cost. Like we cannot optimize it as much as possible, because if we optimize this thing, then we will break this particular way of interacting with Python. Or if we optimize this thing, this kind of code will be broken. So unfortunately, we kind of shoot ourselves in the foot because we make a super flexible way to interact with the language. The problem is one of the reasons Python is now so popular. But now that Python is so popular, people want the speed, but we cannot break those existing ways to interact with the language. and therefore we cannot optimize it that much. There is still a lot of room, like, PyPy as a different interpreter, they do things differently. The cost is much more complicated, and is less well, I mean, can be a bit more or less maintainable, but it's more complicated. And also PyPy is not as fast as Python actually when interacting with C and C++, because they try to make sure that Python code is as fast as possible. PyPy can be even, I think, 100 times faster than Python for Python code. But when it tries to interact with C code, it's actually slower because it needs to simulate all this interface that we were talking before, and that has a huge overhead. So you're using machine learning on PyPy, probably, I mean, you should check, but probably, or up to this point, it was slower than in normal Python. Also, it doesn't have the latest and greatest features, right? I think Python 3.7 or 3.8. So yeah, that is one of the reasons. But I would say the first one is money, probably, because if you have enough money, you can do whatever.
Okay, I see. And many times even I have seen like some naive and new programmers who, let's say, who are doing like a huge like number crunching, and they use like Python list. And I'm like, dude,
Right.
use NumPy, right? NumPy, the whole reason NumPy and Pandas is there is for it will give you a speed. And when they start using the correct libraries, the performance improves by a whole lot. So of course they should be using these libraries, which gives you C++ speed. But as far as the language itself is concerned, there must be some initiatives, right? Like speed.python.org is one where kind of you are kind of one of the main person. So
we care a lot about the speed for sure, and we spend a lot of time optimizing Python code and the C code. Like, we put a lot of effort. I myself work a lot in this area, and it's quite difficult, but we put a lot of effort and a lot of time for sure. So we are trying to make it, actually Python 3.10, for instance, it can be up to 10% faster than previous versions because we have optimized some parts of the evaluation loop. So you can go to the what's new page in Python 3.10 to see what we're working on. But I mean, I will say the following as well. If you're trying to make sure that something is fast in your Python code, first, make sure that you are using the correct algorithms and data structures, because even if Python is slow, if you're using the incorrect algorithm, or you're doing a bad choice of data structure, it will not matter. It's just the constant. Once you have your better algorithm data structure, then you need to see if you're using a framework, like if you're using Pandas or TensorFlow or whatever. Now try to make sure that you are choosing the right abstractions in your framework. Sometimes doing some things in Pandas in a particular way is 10 times slower as doing it another way. So try to understand your frameworks and try to make sure that you understand what is the correct way to make it as fast as possible. And once you have that already done, or you are not using a framework, then you can say, or actually, let's do this thing in C++, right? Let's do a library, or let's use Python or whatnot, right? But don't forget about, like, still the correct choice of algorithms and data structures is super important, right? Like,
exactly.
Many times, I will not like so many times someone has come to me and say, oh, Python is so slow. Look, I have this code, and like if I do the same thing in C++, it's like 100% faster. And I grab the Python, and without doing any C++, I do some changes. So I choose different data structures or something from the standard library. And now it's like maybe C++ is 4 times faster. Because look, like Python is also quite important. Like Python is also written in C. So Python itself is a compiled thing. So we have C speed underneath. I mean, obviously, when you have like all the structures of the language, there is a huge overhead, right? But if you know how to do things in a way that leverages as much as possible that C code, so it doesn't use a lot of iterations in Python, you can actually run a huge amount of things in like you can have like a lot of data speed available. I mean, not as fast as doing it natively, because still there is overhead for the objects and the dynamism. But if you know your things, you can certainly make it much more efficient, right? So yes, it's slower. Like, we are not trying to hide that, but there is many layers of what means to be slow, right?
All right. Now, Python was released, the first version, in 1991. So it's been 30 years. But only last 10 years, it has gained so much popularity. What is the reason behind that?
Well, the two main bursts of Python popularity was Python for the web, as a web framework, like Django and Flask and other things in a like a lot of people normally want quick backends. So they say, okay, or like very easy to evolve backends for their web. So Python was a super popular choice, and still I think it is. Although now JavaScript, even for the server, has some popularity now, or even Rust. But it still is a strong thing. Like Flask and Django are still very popular projects. Like Instagram, for instance, is written in Django. So even like big companies still use this thing as a way to evolve. Although there is other problems there, but any big thing will have problems anyway. YouTube is also written in Python, for example, or it was. Now probably it's a mixture of Python and C++. But the other burst was numerical computing. Like people from the scientific world started to use Python a lot, and now it's machine learning and data science and whatnot. So that is one of the reasons it became so popular, is because it was it had this feedback loop with the disciplines, right? Like a lot of people started to want to do machine learning, but a lot of people starting machine learning didn't need programming, but Python was very easy to do, and Python evolved hand in hand. For instance, Python, we added the matrix multiplication operator back in the day because a lot of people were using Python for numerical computing, and doing matrix multiplication with an operator was quite handy. So not only kind of Python jumps into the trend and people start using it because it's easy, but also Python evolves because of that, right? Like, okay, so Python is now used for numerical computing, so let's make the language a bit more easy to use for numerical computing. But yeah, those are the big bursts, and those bursts happen in the last 10 years. So that's probably the reason. And like in the enterprise world, when a lot of these things start counting as popular, uh, it's a slow beast. Like companies evolve very slowly. They don't just grab. Like Python was always there, like for scripts and things like that. But for big things, until there is what they call a killer application, like until you heard that, oh, Google used Python for YouTube and YouTube is super big, or Instagram, or what is the other one? There's many of them, right? So until you hear these big projects done in Python successfully, companies don't start considering doing Python for big things as well, right? So that took a slow movement, right, until it exploded. And once it exploded, it's exponential. So everybody wants to jump into the trend, and it happens with every language, right? Like Rust right now. Rust is super popular and everybody wants to do Rust, but if you go to the companies, nobody's doing actual Rust. I mean, there is very little companies doing it. Even if everybody speaks about, it's fantastic because this and that and this other thing. Like, the company war is slow. You need to have infrastructure in your company for that programming language and libraries and a team that understands that. So it's a slow process. Probably the success of Python in the last 10 years was also being baked before, right? And it was exploding
right now
afterwards.
And I say like rapid prototyping is probably one of the reasons why it's popular, because we live in a very agile world where companies want to build like fast prototypes. And when it comes like building something fast, I think Python is the language. It's more like English, like the syntax, everything is like so super convenient. Even like high schools, like when they teach language nowadays, I mean, I have my nephew, he's in high school. They select Python because it's just easy to learn.
Right. Also for you, like for when you say like it's very easy to quick to prototype, it's not only the language, it's also the ecosystem, right? I mean, it doesn't matter how easy it is to write something in Python. If you're going to write, like right now, again, machine learning, right now you can do a neural network in 4 lines because you have keras and TensorFlow, but like good luck if you don't have those. It doesn't matter that Python is easy to work. You probably are going to write like thousands of lines of Python, right? So another reason probably to add to the list is that the ecosystem is big enough. I mean, it's a kind of vicious cycle. Like one has a feedback loop on the other, but the fact that you can easily prototype things is because there is a good ecosystem, so you don't need to write a lot of these things yourself. You can just pick from here and here, and then you glue those together.
This reminds me of my college project. It was like handwritten character recognition. I implemented the whole backpropagation in C++. It was like a 3-month project. I coded for 3 months, and now doing same thing, just 5 lines, done.
Right. I can say the same thing for my PhD. Like I spent making a simulation of black holes in like probably even a year, and now you can do it probably in 10 lines of Python because there is libraries that do a lot of those calculations very efficiently. So I don't know. I mean, it's progress, right? That's how it works.
Cool. So 3.10 is coming this year. So you want to talk about any features? I mean, you said like there's a page where they have listed, you guys have listed the features, right? Sure.
If you go to Python, if you search in Google Python 3.10, what's new? We have a page that is evolving, so that will be complete when we release Python 3.10. But that you can see all the things that we added, and I'm quite excited. There is a lot of interesting things. There is performance improvements. There is new syntax for annotations. Now it's a bit easier to write ORs. Who knows? Maybe we will have pattern matching. That will be a super big addition to the language in 3.10, but we are still deciding it in the steering council. There is. I'm quite excited about a couple of things I added in the parser. So there is parenthesized context manager, which was also available on 3.9, but was not official. Now it is. And I added a bunch of new better syntax errors. So if you, for instance, don't close up, actually, maybe I can share. Can I share?
Sure. You can share. Yeah.
Okay. So can you see this?
Yes.
Okay. So cool. So this is Python 3.10, the 4 alpha, right? So look, I'm going to open a file here, which is, doesn't matter, some text from the standard library. And here is this big dictionary over here. And what I'm going to do here is that I'm going to remove the bracket, the closing bracket. So now, obviously, this is invalid Python. But I want you to look particularly at this line over here. So I removed the bracket on the previous line, but this line here is the next one. It says actually and some list comprehension, and it's correct Python, right? If you go and execute this file right now with Python 3.8 on 3.9, let's try to use 3.9 for instance, look at what happens. It says syntax error, but look at what it's pointing at. It's pointing at to this line. And it's saying actual equal blah, 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 blah. And it says syntax error. And look, it's quite confusing because if you go here and then you start Python 3.9 and you copy this line, it actually works. It's not a syntax error at all, right? Look, actual, now it's something. So it's not a syntax error. The problem here is that because I removed the closing bracket here, Python still, when it parses this code, it still thinks that this line is part of the big dictionary here. And obviously it sees the equal and says, yeah, that doesn't make sense. But that's not the error. The error is that you forgot to close this thing. I execute this thing with Python 3.9 and it says, yeah, there you go. It says, oh, what is this? This is wrong. But now you execute this thing with Python 3.9, it tells you, oh, actually you forgot to close this bracket over here, right? That's much better because look, if you have a file, for instance, let's create a file here, and then you do this experiment, but imagine that you start writing your list and say, okay, I have my list. So I have like, the horriblest list in the world, but let's do something, right? So you put some elements here and even, oops, sorry. So this, so this list can be like super big. So let's do something, like quite long. And let's say you forgot to close this bracket over here, right? So if you execute this thing with Python 3.9 or any other Python before, look at the error. The error says, syntax error, unexpected end of file while parsing, and it's pointing to nothing. It's pointing to the end of the file, line 11. This is horrible because the actual problem happened on the first line, and it's pointing to the end of the file. So it's quite difficult to know what's going on. But if you execute this thing with Python 3.10, it tells you, okay, yeah, you forgot to close this particular bracket. And this is just an example. I mean, there is it's not only that we added this thing. There is many other improvements that we did, so we can show you much better errors when you commit these problems. I mean, this may seem like a small thing, but imagine that you are doing this thing, right? Imagine that you're coding and then suddenly it says, oh, syntax error in this line, and you say this doesn't make any sense. You can spend literally 10 or 15 minutes trying to understand what the fuck is going on, and then suddenly you say, what? I forgot this close bracket, right? Oh, haha, that was right now. You don't spend these 15 minutes. You just tell it. So it's quite important, especially you're learning, right? Like for those of you that are learning Python right now, these errors are quite good. So even if it's just because of the errors, I will consider certainly using Python 3.10. And we have a bunch of those improvements in Python 3.10. So I will encourage you to try them out.
Certainly, this is very good actually, especially when you're working with a huge code base, and when you have like 15 different errors, and it really can confuse you versus like if you have understanding of where exactly it is happening, you can resolve those errors very fast. So one of the questions that was asked was, mobile app development is big, right? Everyone wants to develop a mobile app, and Python is not like JavaScript nowadays, JavaScript, Dart, those are the languages. So are there any plans or thinking of making Python a first-class citizen for mobile app development?
Right. There is some conversation already started. I think 1 year ago there was some conversation in one of the language summits, which is a meeting that happens at PyCon when it was in person every year, and many people from the Python community go there to talk about whatever. And one of the people, Russell Kim McGee, I think, he came there to speak about Python on Android and macOS, and like how to make that possible. It's a lot of challenges, right? There is some conversation started. There is still we know that there is no work started, but there is a lot of conversation. Even in the steering council, we know that that's something that we would like to have. So it's even on the vision. It's just that we need to figure out how to overcome those problems. The main challenge, there is plenty of challenges. One of them is a build system problem. Like when you build Python, it builds an executable for your architecture, and that's done. And in phones, you normally need to build a different executable for different architectures, like AMD64, but also ARM, etc. Right? And right now, that's not easily possible. But also, phones are quite like they don't have the same interface as operative systems like Linux and Apple, for instance, and macOS, iPhone or iOS or whatever it's called. The difference is because you cannot have like Python that doesn't care about your resources. It will literally exhaust all the memory, all the processing power, and they don't have all these APIs that are required. And also, you cannot just, for instance, you cannot just easily spawn processes in a phone. You need to use different kind of ways. So we need to add those APIs to Python itself, and also we need to rethink about a bunch of the standard libraries so it interacts with these APIs in a better way. It's quite a lot of work, but it's certainly easier than other big projects that we had. So there is some conversation started, but no work is being done right now, as I know. There is people that already. So in any case, you can still build Python on Android. There is people that do this thing already, so that is still possible. And you can execute Python on Android. Actually, you go to the Apple Store or the Google Store, you can have Python on your phone as like the horriblest experience because you need to type, you need to code with the phone keyboard. But that Python works in Android, right? Like you can execute Python code in Android. So it's certainly possible. It's just that for having a good experience because when people say Python on phones, they don't say Python on phones. They want Python and the ecosystem on phones, right? They want to run NumPy on phones, and they want to run Keras on phones, or they want who knows, right? So it's not only just I can write Python language. No. They want the whole thing. So that's when it becomes very difficult. And there is some conversation started, but nothing worked right now. Who knows? Maybe this year there will be some starting. But yeah, I mean, it's not that it's light years away. It's already possible. It's just that someone who has a lot of experience and knowledge about how Android and iOS work, they can help us. Not only just making the code, they need to make sure that we can test the code on those phones in an automatic fashion. How do you test code that works in Android in an automatic fashion? GitHub doesn't offer a Travis CI or GitHub Actions for Android that I know of, right? So how do we make sure that if you change something for Android, that code works? Like we need phones somewhere running the test suite, right? So it's a lot of infrastructure as well. And both Android and iOS are very tightly controlled by corporations as opposed to Linux. And you will argue that Windows and macOS are always controlled by corporations, and they are, but it's easier to work, like in the sense that it's more open and less strict and tight about what they do. So it's a different kind of. It's more difficult to have good platform resources on those as a Python core developer. So I don't know. Who knows?
Cool. One last question. So let's say I'm a college student or a software engineer who have never contributed to open source. And even a person doesn't need to be a software engineer. You are a physicist, right? And you started contributing open source. So if someone wants to contribute to open source for the first time, what are the tips that you would give to that person? And also, why is it even important to contribute to open source. You're not getting paid after all.
Right. I mean, why is important? There is many areas. Every person has a different reason to answer that. I would say that the reason is important is because if you buy into this, I mean, people should, but I understand that it's not the only motivator for a lot of people. The reason right now you can work on, or part of the reason you can now make a neural network in 4 lines is because open source, right? So you're taking the library of someone who wrote that in their free time. So to make sure that this continues, and there is more libraries, and the whole thing keeps evolving, is this concept of giving back. You have used this thing for free, maybe you have even make money, or you work in a company and your company is making money out of that. So there is this concept of giving back. Okay, so I have made all this money, or I have made all this experience, so I can do my project in 3 lines, so I will try to help a bit, right? You don't need to create another library or to be years there, but like everybody contributes what they can, right? That's how charities work, and that's very similar to what open source work, right? So there is this concept of trying to be respectful with the community and say, I use this for free, let me try to improve this other thing, right? It doesn't need to be even proportional. You may have companies make millions and millions of dollars in open source, that they certainly don't give millions and millions of dollars back, but like at least they give something, right? That is one concept. The other concept is that for developing your skill set, like your skills and your getting better, open source is fantastic for that. It will put you in a position where you will work very closely to how companies work. So if you are interested on the software engineer market and you want to work on companies, or you want to make your own, or you want to make a product or whatever, the way people work in open source is different from how they work in companies, but it's close enough. Like you will interact with people the same way you probably will interact with them. You will use similar systems, similar concepts. You will see similar challenges. You will learn how to communicate a bit better. And also, I think that's quite important for myself as well. You will be able to interact with people that are, very smart, but the important thing is not how smart they are, but also how much you will learn from them. So you will be able to interact with people that you will be able to extract a lot of information from them, and you can learn how they work very closely, right? So maybe you make a PR to Python, and maybe Guido Van Rossum reviews your PR and then tells you, there is a better way to do this thing, which is this and this, right? And then you say, I learned about how to do this thing better, right? I mean, and I say Guido, but it's not about how famous you are. Maybe Victor Stinner or Judy or Marietta or Carol appears in your PR, right? You can learn from them a lot, right? So it's not about how famous people are. It's about how much you can learn from them. So and open source is certainly one of the best ways. Like you want to be better at a software engineer, contributing to open source is a fantastic way. I mean, it's a bit weird, because if you consider this thing as a doctors don't do surgery on the weekends, and say like, okay, let me do some free surgery on the weekends, and that's how I will become a better doctor, and I will learn from the best doctors that do surgery on the weekends. It's quite weird if you think that way. Like, if you tell them to your family and say, I work for free. I work for free because, giving back, and I learn from the best, and they would say, that's so weird.
Well, open source surgeries might be a big concept, but the question is, who will be the patient?
Right. Well, I mean, if you think about that, look, it's quite a contrived example, because like, look at this. You see, like, exactly who will be the patient, right? But look, like in open source, everyone is the patient, because at the end of the day, Python runs on some machine that probably is making your X-rays or whatever, right? Or is working on one of the big companies that making the finance prediction, and therefore impacting your retirement funds or whatever.
That's true.
So the patient is everyone. Like, and if there is a bug on whatever library, maybe that machine doesn't work, or maybe the economy crashes, or who knows, right?
Or maybe your code is running on Tesla car. Who knows?
Exactly.
Autonomous car.
Like, think about this. I always think about this as a funny thing. So Python is super popular and it's everywhere, right? Like almost everything uses Python. A lot of things for certain do. So sometimes I think, when I merge some code on my own, or I'm reviewing some pull request from someone and I merge it, I think, well, there is the possibility that if I merge this code, Python becomes less efficient. And because it becomes less efficient, it consumes more energy, and therefore speeds global warming. So
Wow.
there is the
environmental impact.
and you will think like, what a stupid thing, but look, Python is running millions and millions and millions of servers. Like, it's a huge amount of power being consumed. So, if I make iterating in Python a bit faster, you are making a huge impact, just because there is so many ridiculous amount of servers running Python. All the companies, right? So it's quite, the patient in open source is quite a big patient. Yeah. So I don't know. It's quite weird in the sense that it's a different style, but it's not super different from charity. I mean, if I tell you now, okay, maybe doctors don't do surgery on the weekends, but certainly if they tell you that, okay, but maybe doctors work for free on the Red Cross, or they work for free on, I mean, maybe it's less common. Certainly when they apply to some company, they don't ask you for, do you do some free doctor work on your own time? But like, it's about more close to charity than other things. But yeah, there is this thing. So I need be prepared to explain to your friends and family the concept of working for free. But I find it nice, and I find it, or even as a hobby, you can feel it as a hobby, right? I love to code. I like solving problems. I like helping people, so I can do all of that in the same packet. But it's about what you like, right? Like, some people run, I know, their association of cinema lovers, and they talk about cinema, and they maybe do some projections all for free, right? So it's the same thing, but impacting more people.
And I always say, like, sometimes people argue, let's say, I on my channel, I interact with a lot of college students, and they're like, oh, we barely started learning programming. How can we contribute? And I always say this thing, which you mentioned previously, which is contribute to documentation. At least when you contribute to documentation, you understand the whole process end to end, and then pick up a small bug, like, maybe a few lines of change. And that's how you evolve. You don't have to be like, you don't want to be implementing like next like big feature in Python. Right? Of course, it requires a lot of practice and work, but yeah, we can always start small. So
actually, that's a fantastic idea. One of the reasons is because only when you are learning, like, when you know your stuff, you become less useful for the documentation. I mean, you can still contribute, but when you are learning, you are the only people who will read the documentation for the first time, and therefore will know if it works or not. So right now, if you're starting, like, you're looking this and you're starting to contribute to, so you're starting to learn to program, and then you're reading the documentation and something doesn't make sense, or you don't understand something, you're the perfect person to go there and say, this doesn't make sense. Because we all that already know how it works, we will write the worst documentation. We will know where the problems are, because the documentation is actually not only for us, right? It's mainly for you. So you have now the superpower of telling us, this doesn't make sense. Please explain it a bit better.
All right. So I hope this message goes to everyone, and probably you will receive few hundred pull requests next week for the documentation.
Hopefully.
Yep. All right, Pablo. Thank you very much. Those are all the topics we had. I really appreciate you sharing all the insights of your Python Steering Council, your open source, and all your experiences. If you have any last like closing thoughts, you can share it.
No, thank you very much for having me here. I have a lot of fun, and I hope that people enjoy the conversation.
Yep. Thank you. Bye.